things that we're hitting in this section is just all of our exponential rules and logarithms. Okay, we know exponentials and logs are very closely related. Hopefully you remember that. They're inverses of one another. So just starting properties of exponentials. What is anything to the 0 power? What does a negative power do? No, flips it. So if it's on top, it moves to the bottom. If you have a fraction for a power, what does that mean? So when you make your root, the denominator is your index, and the numerator is just your exponent. So if I said like 27 to the 2/3 power, what that means is the cube root of 27 squared. And it doesn't matter if that square goes under the radical or outside, it's the same answer. So what is the cube root of 27? 3. And 3 squared is 9. So a fraction means a radical. Fraction exponent is turned into a radical. If we are multiplying and the base is written each time, what do we do with the exponents? If we are dividing, what do we do with the exponents? If you have a power to a power, what do you do with the exponents? And finally, if we have one term inside the parenthesis and an exponent on the outside, what do we do with that exponent? You guys remember doing most of this, hopefully? So first few examples, we are just simplifying exponentials. So writing this in its simplest form. Where would I begin? You have to start. Think order of operations. You begin with your parentheses. Okay. There's nothing to really work out in my parentheses, but the next step is exponents. Now that cube has to go to both things in here. This is currently like a 3 to the first. It's a power to a power, so you multiply those exponents. So it becomes a 3 to the third x to the 6th. Okay, what is 3 to the third? And these, the x's, are both written, so what do we do with the exponents? 27x to the 10th. B. First step. Do we have any parentheses? Okay. Exponents. Do we have any exponents that we can simplify? Okay. Next step, multiply. Can we multiply anything? Yeah. If I'm multiplying on the top, this base is written each time. So what do we do with the exponents? Add them. So 2n plus 3n would be 5n minus 1. Okay, then how do I divide this? Okay, so I have to think about this exponent minus the denominator. So if I distribute that negative, 5n plus negative n, 4n, negative 1 minus 2, negative 3. So you get x to the 4n minus 3. Why don't you guys see if you can simplify those two? Let's see, this means the cube root of 8 to the 4th. You can do the 8 to the 4th first if you want. Thank you. On a test, when you don't have a calculator, you might want to do the cube root first, just so you have smaller numbers. What is the cube root of 8? And then 2 to the 4th? 16. Alright, D. So first we need to deal with these exponents outside the parentheses. So we have a 5x to the 0. What would this negative do to that whole thing? Can I go ahead and put that on the bottom? So it's going to take that 3x squared and it would then be to the positive third. Here, this would be a 5 squared x to the 8. So on the top, 5 to the first times 5 squared, so that's 5 to the third. X to the 0 times x to the 8th, you just add your exponents, 0 plus 8 is still 8. On the bottom we get 3 to the third, x to the 6th. What is 5 to the third? 5 times 5 times 5. If we have x's on top and bottom, what do we do with the exponents? Subtract, so 8 minus 6 is 2. And 3 to the third. 3 times 3 times 3.
Wait, how did we get 5 cubed again?
We had 1 5 here and 2 here. So that was 3 altogether. So you add those exponents. Yes?
I thought 5x to 0 was 1.
The x portion is. So the 0 is only touching the x here. So x is 0 is 1, so you could drop that out and make it a 1. And you should get the same thing. Other questions? Look at some more. If both of these exponents are negative, what could we do? Flip it. So the 4 to the negative third, that would go to the bottom. 2 to the 8th would go on top. Alright, there's different ways of simplifying this. So, what is 2 to the 8th? 256. What is 4 to the third?
64.
Does that reduce at all? We divide them by 4. What does that give us? No, it just is 4, isn't it? Is that okay? Alright, F. In the radicals, it's a little bit harder to think about. A square root is what power? 1 half. So this whole thing is to the 1 half. And then I have an x, and then I had another square root of xy. So that xy is to the 1 half. On the bottom, that was all to the 4th root, so that would be a You're a step ahead of what I wrote down, but yes, that's correct. Okay, so if I start simplifying this, in this one I have an x times x to the 1 half, y to the 1 half, and there's still this 1 half out here. In the bottom, if we distribute, we get x to the 3/4, y to the 5/4. Okay, this is an x to the first, so what do we do with those exponents? Add them. So 1 plus 1 half, that would be 3 halves. And then what do we have to do with this 1 half? Multiply power through power. So that would give me x to the 3/4, y to the 1/4. So So I kind of combined a couple steps there. Is everyone okay with what I did? What do you notice about the x's now? These are the same, so they would cancel out. Y's, do we have more on the top or bottom? Bottom, so it will end on the bottom. So you subtract these exponents, so 5/4 minus 1/4. 4/4, which is 1. So we just get 1/y. So when you have those radicals, it might be useful to write them with fraction exponents, and then you can use all of your exponent rules. Any questions?
Why do we only distribute the x on the very first part to the other x?
Because all of this is multiplied together. It's just like x times x to the 1/2 times y to the 1/2. And multiplication you can do in any order. So I just multiplied the two y's. Now, if there had been a plus sign between those, then you would distribute it to both. But it's because they weren't adding, it was all one term. We're just multiplying, so you just multiply in any order. Other questions? Let's talk a little bit about the graph of an exponential. When we plot them, what three numbers did we always plug in for x? Okay, so we are going to look at a couple of these graphs. We'll do the parent function and transformations just like we've done before. The parent function is just your exponential. So like 2 to the x, 3 to the x, 4 to the x. An exponential function is when the variable is the exponent. So you have a number to the x power. That is an exponential function. Okay. So those would be our parent functions, and to get an idea of those graphs, we just plug in the points -1, 0, and 1. And then we can use all the same transformation rules that we were using in the last section. So if I wanted to graph this function, if you prefer, we could write this as a -2 to the x plus 3, if you want to flip the order around. What would I use for my parent function? Parent function is one of these, just your basic exponential. So in this case, it would have to be 2 to the x. So we do our 3 points. You don't necessarily have to write out the t-chart, but I'm going to, for this example, to talk about what I'm doing. If I plug in a -1, what would be 2 to the -1 power? 0, 2 to the 0. And 2 to the first is 2. So we have -1, 1/2, 0, 1, 1, 2. You could do more points if you plugged in a 2. 2 squared is 4, so you see this is just going up. Will you ever do 2 to a power and get a negative answer? No. Will we ever get 0? Does 2 to some power ever equal 0? No. So if you remember, exponentials, like this, they had a horizontal asymptote at the x-axis. So that's my parent function. Transformations. What does the negative do? And the plus 3? So if I flip this point, so we'll go down to -1/2 and then up 3. I flip this, goes to -1, then up 3. And then -2, up 3. Maybe it's a little bit difficult to tell what's going on here, but when we did these transformations, I also told you you need to move your asymptote. So we had a horizontal asymptote at 0. The flipping doesn't move that, but when I go up 3, that means positive 3 is the horizontal asymptote now. So the graph looks something like this. You need to make sure you are including those asymptotes on your graphs. Domain. Looking at a graph that's going from left to right, it keeps going in both directions, so that would be negative infinity, positive infinity. The range is my y going from the bottom up, so it's coming from negative infinity, and it stops when we get to Is that one okay? Well, let's see. If it's easier for you to think about, you're welcome to write this as 3 to the x minus 2. I want you guys to try to graph the parent function and the transformation. 3 to the negative 1 is 1/3. If you put in a 0, 3 to the 0 is 1. If you put in a 1, 3 to the third is 3. Or 3 to the first is 3. So parent function looks like this. What was our transformation?
Down to.
So your horizontal asymptote moves to negative 2. So domain. Range. Are those okay? Did you figure out the domain on the next? No, a little tricky.
No.
I did something.
Did some things. It's a square root, so what do we know about the thing underneath? Has to be greater than or equal to 0. So if you subtract a 1, if you divide by a negative, what's that do to the inequality?
Flip.
Okay, so 2 to the t is less than or equal to 1. Okay, that might be kind of hard to think about, but if you think about the graph, or actually we graphed 2 to the x power already, didn't we?
Mm-hmm.
When is this less than or equal to 1? What makes it equal 1? At 0, and it's below 1 before 0, right? So if we use that graph, it's less than or equal to 1 right here. So it would be, and my 0, because 2 to the 0 power equals 1.
Oh.
So t is just like the variable x here. I'm saying for what x values is this less than or equal to 1? So if you think about your 2 to the x power, that's what the graph looks like. It equals 1 right here. The y value is less than 1 before we get there. So then you're giving me the interval for the x's, so it's coming from negative infinity, and we have to stop when we get to 0, because after 0 it's bigger than 1. B. If you have a fraction, what do you know? So e to t can't equal 1. What makes this 1? E to what power would equal 1? So t can't be 0. So negative infinity to 0, union 0 to infinity. Everything except 0. So when you see that e, we will see that a lot in calculus. That's called The natural exponential, you're probably more used to when we see logs, the natural log we talked about a lot. In calculus, that's the log and the exponential that we will use 99% of the time. Okay, so that is the most common one. If I ask you to graph it, same thing, E just represents a number, kind of like pi. It's 2.7, and then you have this lovely decimal that goes on forever. If you wanted to graph it, we need to plug in -1, 0, and 1. E to the -1. You can use your calculator. You have an E above the natural log, so if you hit second natural log and the -1 power, what do we get?
Woo.
About 0.36, so less than half. E to the 0, anything to the 0 is 1. E to the first is about 2.7. So the points are not pretty, but we could graph them. Transformations. What would the negative on the x do? Over. And what would the -1 do? So I currently have a horizontal asymptote at 0. So if I go down 1, my horizontal would be at -1. So move each of these points down 1. Oh, but then I have to flip it over the y. So when you flip, this one wouldn't change. This one will come over here, and this one goes over here. It looks something like that.
I have a question.
Yes.
My graph is not right. So what am I
Or so -2.
So why am I making those like that?
I'm taking x and making it. Other questions? All right, we have two options. I can either probably finish this if I keep going today, or we could stop for today and start working on the homework. So either way, we can either have a work day Monday or keep going, or stop now and then finish it on Monday. Preference? Work day Monday? You good with me just finishing this? So properties of logs, these are very closely related to the exponentials. The actual definition of a log, the base of the log is the same as the base of the exponential. And then remember we always drew in these arrows, so that means a to the y power equals x. So the answer to the log is that exponent. So if I said log base 2 of 8, that means 2 to what power would equal 8? 3. Okay, so the log is finding an exponent. Properties of log, if you have the log of two things multiplied together, how do we break that up? Log base a of x plus log base a of y. If they are divided, what do? Log base a x minus log base a y. Do you guys remember when you had an exponent, what could we do with that? Turns into a coefficient. Common log, if you hear me say that, you'll just see the word log. That is a base of 10. So anytime you see log without a base, the base is assumed to be 10. Natural log, that's the ln. That one has a base of e. So on those two forms, the base isn't written. It's assumed that you know what they are. All right. So let's graph a couple of these. Can I change one of these? Do you care? I'm going to make this one not the natural log because the points aren't very nice, and I think it's easier to see if we look at a different one. So let's say I said log base 1/2 of x. Okay, to graph these, what we always did is change them into exponential form. So f of x is the same as what variable? Y. So it's like saying y equals log base 1/2 of x. So in exponential form, that means 1/2 to the y power equals x. If you make your t-chart, we've been graphing exponentials, and I told you with exponentials we always plug in -1, 0, and 1. So I'm going to put those in for my exponent, but the exponent is my y. So what is 1/2 to the -1 power? 2. 1/2 to the 0, and 1/2 to the first. So my points, 2, -1, 1, 0, 1/2 1. These are related to the exponential. The exponential had a horizontal asymptote. These have a vertical. They're never going to hit that y-axis. So second one, g of x is the same as y, so y equals log base 3 of x. It's 3 to the y power equals x. So y is the exponent, so that's what we plug in the -1, 0, and 1 for. 3 to the -1, 3 to the 0, 3 to the first. -1, 0, 3. Again, you have a vertical asymptote, just like the exponential always has a horizontal asymptote. Is that okay? So if I ask you to graph a log, just change it into exponential. Use the laws of logarithms to evaluate log base 2 of 80 minus log base 2 of 5. So think about those properties of logs we wrote down. I have two logs being subtracted. If I wanted to put these back together, what am I going to do with my arguments? So 80 divided by 5 is 16. Remember what this means. It's like saying 2 to what power equals 16? Last slide of the day. Find x. Okay, natural log of x equals 5. It's not as obvious here. So if you have a log and you don't know how to solve it, what could we change it to? Exponential. What is the base of a natural log? So this is like saying e to the fifth equals x. And that's my answer, e to the fifth power. B. So if I want to change that to exponential, the base is e, so what would I write? So then, what? So e to the third is not pretty. I'm just going to leave that as e to the third plus 1. How do we get rid of a square? With that, x is plus and minus the square root. You cannot because it's more than one term. Because of that plus 1. You can't. C. Do I know 2 to what power would equal 3? No. Any ideas what we could do? We could write this with a log. Different ways to do that. We could do like the actual definition. In college algebra when we did these, we usually wanted ones that we could put in the calculator and get a decimal answer. So we added just a regular log on each side. Properties of logs, where do your exponents go? So x minus 5 times the log of 2 equals the log of 3. I'm trying to get to my x. So what should I do with that log 2? Okay. Final step to get x by itself would be to add the 5. You could put these in your calculator and get a decimal, but tests and quizzes, we don't have one anyway, so I would expect you to just leave it like that. I think I have time. Last example. So it's very, very similar, and we could do it the exact same way. However, when we have e's, what kind of log is nicer to use? Natural log. You don't have to. You can do it with the other log. But it'll just clean up a little bit better if we do the natural log. So if we add our natural log to each side, the thing is, if the base of the log and exponential are the same, they actually cancel. So that natural log of e just drops out. We have 5 minus 3x equals the natural log of 10. So we can subtract our 5, divide by negative. I know that's a lot. I really just reviewed like an entire chapter of college algebra in one day. So a lot of stuff. We're just trying to make sure we remember our basic rules so that throughout the year as we come up with problems involving exponentials and logs, we can simplify them and turn it into something more usable. So I went ahead and gave you the handout in case you want to get started on it, you have some downtime. It will be due on Tuesday, so Monday you will have class time to work. I will also probably give out the study guides for this first chapter on Monday.
No problem.